Hello everyone, I am Vaishali Rastogi. So today we are having the topic of look ahead carries adder. First of all, we should understand what is look ahead carries adder. Is basically a carry look ahead adder. First of all, we should understand what is carry look ahead adder. We also call it CLA. A CLA is a type of a fast parallel adder used to solve the calculation in digital logic to calculate the carries with the advanced inputs and all the signals. So first of all, we should understand what is carry look ahead adder. We also call it CLA. Basically, CLA is a type of fast parallel adder used in digital logic to calculate the carry signals in advance from the input signals. Basically, it also reduces the carry propagation time and implements addition of binary number. It is also known as ripple carry adder and carry look ahead adder or generator fast adder with carry predictor. So whenever you can see that it is also known as carry look ahead adder generator as well as fast adder or carry predictor. It is an improvement over ripple carry adder circuit. So first of all, we should understand the basic working architecture of 4-bit adder circuit. So here you can see that we are having some structure. We are having some adders like full adders and half adder. So whenever we are adding some kind of digits, but we also having some carry, we use this kind of architecture. Here you can see that we are having some numbers like A0, A1, A2 and A3 and B0, B1, B2 and B3. Also we are having some carries over here. These carries are basically carry forwarded to another adder and this one is our initial carry. Maybe it can be, we can have an initial carry or sometimes we cannot have any kind of initial carry. So after the completion of this circuit, we can have two kinds of output like some S0, S1, S2, S3 and some internal carries. These carries are final carry. So to understand all the functionality of this complete adder, we have to see the basic initial working of single pole. Before that, we should understand what this mechanism is going on under the working of a carry look ahead adder. Basically, we have input signals A, B and C in basically a carry. If we consider the addition of these three variables in every possible case, we can get a truth table like this. Here you can see that here we are having A, B, C in and C out. A and B are the normal inputs and C in is our basically carry, which is carry forwarded from the previous adder. So what would be the C out means the next carry. Basically whenever we are adding 0, 0, 0, we can have a carry 0. 0, 0, 1, we will have a basically carry 0. Again 0, 1, 0, nothing, no carry means none. Again 0, 1, 1, here we can have one carry and this is propagate. I'll tell you what is propagate and generate. Here 1, 0, 0, no carry, none. 1, 0, 1, 1 carry which is propagate. 1, 1, 0, 1, here we are also having some carry which is generate. And 1, 1, 1, here we are also having some carry which is generate or propagate. So you can see in such combination, here we can have 4 carries and this can be of propagate or generate. So let's understand what is propagate and generate. For propagate, whenever we are having some inputs like this, like all the combination of 0, 0, 0, 1, 1, 0, 1, 1. Whenever we add all these numbers, what we can have? Some 0, no carry. Some 1, but again no carry, means none. Here again 1 in sum and no carry. But here we can have 0 in sum and 1 is carry. But this function is basically generating one carry, because this is not having a carry which is carry forwarded from the previous number. It is basically generating some carry. That's why this kind of combination we can consider as generate, as you can see here. Okay, but let's suppose again we are adding 2 1 1, but with some previous carry. Some previous kind of number is here, and which are just which is just forwarding some kind of carry to this number. So this number is generating some carry with some propagated carry. That's why here we are also having some 1 and carry 1. This one will be called, we can call it as generate or propagate. But in this situation, 0 and 1 or 1 and 0, these numbers are not generating any kind of carry. But let's suppose these numbers are having some previous numbers, and previously they are having some kind of carry. So here it can generate a carry. So this carry will be called as a propagated carry. Again, I can tell you that like in this calculation you can see that sum is 1 and no carry. But let's suppose any kind of number is generating some kind of carry, like this. In this case, you can see 1 1 is 0 and it is generating some kind of carry to this one. Means this number was not generating any kind of carry, but this number is forwarding some kind of carry to it. For due to this carry, this number is also generating some kind of carry. That's why this carry is called propagated carry. So you can understand here in this case, this is the generated carry, and here in this case this is the propagated carry. This is the meaning of propagate, generate and none case. So in next slide, we can see the logic circuit diagram of a basic structure in carry look ahead adder. So first of all, we should understand what is this diagram. This diagram is basically representing a small part of the carry look ahead adder. Means this complete diagram is only a single piece of this complete combinations of adder. So let's understand what the single circuit is generating the output. Like let's suppose we are having some input A and B. Okay, so consider it as a AI and BI. We can see that. So here we are using 2 half adder and 1 OR gate between them. Here in PI, what we can have as output? AI XOR So in this PI, what we can have here as output is basically PI is equal to AI XOR BI. Means this gate will generate this output. Again in GI, we can have the output as AI dot BI. But in the next step, we can see that this output is the input of this gate. So what would be the final sum? Final sum would be PI means AI BI, we have seen here, and XOR with this CI pin. Means final sum is equal to PI XOR CI. But here, whenever we are getting the final carry, what would be the output? Here in this case, this AND gate is generating the GI, but this AND gate is generating CI and with PI, and the final carry is generating PI dot CI plus GI. Okay, so we are having some equation of final sum and final carry. In the next, for getting all kind of carry equation, we have to just work with these only 2 equations. What are the equation? Is basically sum is equal to PI XOR with Ci, and carry is equal to Pi and Ci plus G. So we will put the value of from 0 to n in this particular equation, and we can have all the carries output. Let's put the value of let's find out all the carries value here. So C1 is basically our first Cin. So Cin dot Pi dot plus G0. For Cin, ऐसे बोलते हैं. For Cin, we can have an initial input as Cin dot P0 plus G0. But for our C2 means for this Cin, the value would be nothing. But this C1's value, we can have the Cin dot P0 plus G0. Again, for this C2, we can have C1 dot P1 plus G1. Again, we are putting the value in this particular equation from 0 to 4. We can have all the carries value. Like in C3, we can put the value C2 dot P2 plus G2 in this equation. But whenever we are just solving this equation, like the value of C2 dot P2 plus G2, we can simplify with this equation. We will put the simple value of C2 here. So what is the value of C2? C1 dot P1 plus G1. It is completely our C2 dot P2 plus G2. And we will just simplify all this equation. So we can have G2 plus P2 dot G1 plus P2 dot P1 dot C1. And again, for getting the output for C4, we can have C3 dot P3 plus G3. Again, we are putting the value of C3 in this particular equation. The value of C3 would be G2 plus P2 dot G1 plus P2 dot P1 and C1. So we have put the value of C3 here, and again P3, G3. We will just multiplying all the values with the P3, then we can have P3 dot P2 dot P1 dot C1 plus P3 dot P2 dot G1 plus G2 dot P3 plus G3. So these are the 4 final equations we can have for our carries. So let's create the diagram of for carries with so let's create the diagram for all the carries while using these equations. Here you can see the circuit diagram of 4-bit carry look ahead adder. How we can draw this diagram? We just need to understand all these equations. We just make some, we will see that so for making this kind of diagram, we have to understand all the equations, and we can create this particular diagram by using these values. Like you can see here that in C2, what we are having, the value of C2 is C1 dot P1 plus G1, C1 dot P1 plus G1. So you can see we are having G1 directly, and P1 dot C1 we are having from here. इसको फिर से लेते हैं. We can see that we can have G1 directly here, and C1 dot P1 we can have from this gate. So our output is ready for C2. Again in C3 we can have the equation like G2 plus P2 dot G1 means G2 directly and P2 dot G1 from here, and P2 P1 C1, P2 P1 C1. and we apply the OR gate among all these values, and we can have the value of C3. And so on with the C4. We can have all these combination while using all these gates. So again we are having G3 directly and all these 3 combination from these AND gates. So this is the complete circuit diagram of carry look ahead adder. But what are the... So now we have to understand advantages of carry look ahead adders. It generates the carry in for each full adder simultaneously by using simplified equation involving in Pi, Gi and Ci. The system reduces the propagation delay. It is the faster adder when compared to other addition mechanism. And what are the disadvantages of carry look ahead adder? The carry look ahead adder circuit gets more complicated as the number of variables increases. The circuit for a carry look ahead adder is expensive, which is also involves more hardware. As the number of variables increases, the circuit implementations required more hardwares. So we have completed the topic of carry look ahead adder, and thank you.